Here's an explanation for the answer to final exam question number 92 in Electricity Demystified, 2nd edition. If you have the printed book, you'll find this question on page 341. We're talking about a superconductor. A superconductor is technically a medium in which the resistance is zero. So the conductance is theoretically infinite. It has no loss at all. Now, of course, in the real world, we can no more get a perfect superconductor, and mathematically perfect superconductor, than we can get a perpetual motion machine or reach the temperature of absolute zero, or the absence of all heat. We can never quite get there in the real world, but we can come awfully close. Some substances, if we cool them down to only a few degrees above absolute zero, which, by the way, is approximately minus 459 degrees Fahrenheit, or approximately minus 273 degrees Celsius. If we can get something down to within a couple of degrees or a few degrees of that temperature, we can make some metals behave as pretty good superconductors. But these things can expel magnetic flux altogether. Or, in theory, they can do that. In practice, not quite, but awfully close. So if we have a magnetic field in which there are magnetic lines of flux passing through the vicinity, the superconductor will expel them. There'll be no flux at all inside of here. So what in effect happens is the permeability is reduced to zero, and that is choice B. Remember, permeability is an expression of how much a medium concentrates magnetic lines of flux. So if this were a ferromagnetic rod like iron, it could concentrate the magnetic flux and have a large positive permeability much greater than 1. But in the case of a superconductor, which can expel magnetic flux, that's in effect reducing the flux density to zero. So the permeability becomes zero. That is choice B.